So today we're going to be taking a look at unit analysis, which is basically just a fancy way of saying unit conversions. We're starting with one unit and we're converting from that into another one. So again, our main idea, we're converting a number from one unit into different ones. So yards to feet, miles to inches, days to minutes, things like that. So the underlying property that's making all of this happen is what's referred to as the identity property of multiplication. And what that tells us is that for any real number a, it can be any number you can think of, that a value times 1 is always going to be a. And then 1 times that a value is going to equal 1 all the time, where 1 is the multiplicative identity. So essentially what this means is I can take anything and I can kind of scale it up or down or anything like that, but as long as I multiply it by what is essentially 1, the value is going to stay the exact same. We see this idea show up quite a bit when we are working with fractions, and the idea of when we are scaling a fraction up or down, we multiply the numerator and the denominator of a fraction by, let's say, 2 over 2, which is essentially 1. Or I scale it up by multiplying the numerator and denominator by 5 over 5, which is also 1, just written in a different form. So we're going to be doing that exact same idea, except now we're going to be applying units to this and converting back and forth between them. But this is the underlying idea and underlying property that's going to make all of this possible. Now, what we're going through these, so I'm going to go through our process that we have. There's a couple ways that you can go through and organize this as you are going through these conversions. I'll show you guys both of those methods because I think they're worth seeing. They're very, very similar, but I think they're worth seeing just for the sake of having multiple ways to go through these. So first and foremost, we're going to multiply the measurement to be converted by 1. We're going to write 1 as a fraction relating the units given and the units needed. So that means if I'm working with the idea of 1 with units, if I have 1 foot, it's the equivalent of 3 feet. So while the raw numbers themselves are different, the units that we have attached to them make those two statements, 1 foot and 3 feet, equivalent to one another. And that's where we're going to be getting this kind of 1 showing up in here. When we have that written out, that's when we multiply things together, and then we simplify the fraction that we get coming out from that. And then we would repeat these steps over and over and over again until we have the desired units that we're looking for. Okay? So this is one of the methods that we have for going through this. And again, I'll show you guys how this pans out when we're going through and actually solving these things. And there's two primary ways, I should say, that I think are most efficient with organizing and keeping track of these things. I will probably deviate from this process just a little bit because there's a really, really nice method, a really nice way to deal with these that doesn't require doing a bunch of number crunching as we're going through the process, which I think is a bit nicer. It's one less thing to worry about as we're converting these things. So I am going to move this over here a little bit. Before we go into actually solving these things, which we're going to do here, I would like to bring everyone's attention to the geometry properties, the geometry info page. So this is the original front side of it, same one I've referenced previously. On the back side of that page, there's a measurement help sheet. So it's got a bunch of conversions written in here for us. So inches to feet, yards to feet, minutes to hours, meters to inches, things like this. So you are more than welcome to use these, and I would highly recommend using these to go through and help you when you're converting through these different units. Primarily because of, I don't expect you guys to have all of these conversions memorized. I think that's horrifically unrealistic. And I've heard and seen instructors that have requested that people know a good chunk of these going into a test. I don't think that's fair to you guys. So you are more than welcome to use these as you're going through and doing these conversions, doing this unit analysis. My recommendation to you guys, make sure you know the seconds to minutes to hours to days. The time one, I'm pretty sure everyone is going to have nailed down here. So if you know that one, you're looking pretty good. I think inches to feet to yards is pretty good to know. But beyond that, if you don't have these memorized, that's okay. Reference this as you need to as you're going through the homework or going through stuff on the test, anything like that. So we're going to be referencing this, or at least when we're going through the conversions, and I'm telling you guys, okay, there's a conversion between this unit and this unit. This is the page, and these are the conversions that I am referencing in that regard. So let's take a look at our first example that we have here. Convert the following. Round your answer to the nearest thousandth. Yeah. So how many seconds are in 1 day? So this is our first one we're going to start with. Now I'm going to jump us over to our whiteboard, blackboard. I keep getting that back and forth there. I'm going to jump over to the blackboard, and we are going to go through our process for converting seconds in a day, or 1 day into seconds in that regard. So as I kind of stumbled on there with how I was saying that, the first thing that we want to do with these is a generality. And again, I recommend this mostly because I see a lot of people, when they're going through this process of conversion, they don't make it abundantly clear for themselves what they are doing, where we're starting and where we're ending. So the question is asking us, how many seconds are in 1 day? So my recommendation to you, somewhere on your paper, somewhere in your scratch work, write out for yourself, what units are you starting in and what units are you ending in? So again, we're being asked, how many seconds are in 1 day? And you don't need to use anything fancy, but something to the effect of this. For example 1, we're going from days into seconds. So we know what unit we're starting in, and we know where we should be ending. So that's our overall, essentially game plan, where our starting point is, where our ending point is. And we need to figure out the steps in between. Now, when we're doing this, labeling and using units is absolutely critical. If you do not have units labeled, this becomes a monumentally more difficult process and section to go through. So labeling is, again, I can't emphasize it enough with this section. You absolutely need to do it. So we're going to go through with our first example. I'm going to show you guys a way you can organize and go through this problem using fractions. And then we'll go through our other method with example 2, which I think people refer to it as the railroad method, but kind of whatever. It's just a different way of organizing it. So our first problem that we have here, we're going from days into seconds. So start off with making a fraction bar. A little bit smaller, we don't need it that big. Make a fraction bar. The unit that we're starting with, we're starting with 1 day. It's over 1. So that's our first thing that we have, and I need to convert this thing from days into seconds. We want to take a look at the geometry properties page, and you always want to look to see with these, is there a direct conversion from what I'm starting with to what I'm ending with? And I'm looking at the page, it's on my other screen, but if I'm looking at that page, there is no direct day to seconds conversion that I'm seeing, and there's not one that I personally am aware of. So that's fine. We can and will go through a multi-step process to get to there. So you say, okay, is there a unit I could convert days in, or convert from days to something else that's closer to seconds? Well, there is. We can, instead of being in days, I could convert this to be days into hours. So what we do, put a little parentheses, and we put another fraction bar. Now, before you start writing in numbers, you must absolutely make sure, again, units are labeled properly. I am trying to convert from days, and I'm trying to go into a different set of units. I'm going to go from days to hours here. So see where our units are lining up here. I have days in the numerator spot. If I want to cancel the unit for days in the numerator spot, then in my new fraction, I need to put days in the denominator spot of my new fraction. And I'm going from days into hours. So my units now, I can see, all right, I have days up top, days down below. Those cancel. I'm now in hours. And now I can fill in numbers. I know 1 day is equivalent to 24 hours. Now you might be looking at this, and when you're going through, you say, well, okay, let's multiply the first fraction, the second fraction. That I would highly recommend you do not do that. And I recommend that because are we in the units that we're looking to be in for the very end? We're looking to be in seconds, but we're currently in hours. We're not done yet. So I recommend let's hold off on doing the calculations. We're going to let the calculator do a lot of that for us until we're in the correct units that we want to be in. So we're looking at this now. We're now in hours. Is there a direct hours to seconds conversion? And looking at the sheet, I'm not seeing one. But I could convert hours into minutes. So again, I have hours in the numerator spot. So if I want to cancel that, in my next fraction, hours needs to be in the denominator spot. In my new units, minutes goes in the numerator spot right here. I have 1 hour is equal to 60 minutes. The hours unit cancel out. Now I'm in minutes. And do I have a minutes to seconds conversion? Yes, I do. So I come over, make one more fraction. I want to cancel minutes to get into seconds. I know 1 minute is equivalent to 60 seconds. The minutes cancel out. I'm now in seconds, which is exactly what I wanted to be in the very beginning. And now I'm done with needing to write out a bunch of fractions for myself. So the really nice part about this, and this will come into play when we have some kind of grosser numbers that show up in the numerator and the denominator spot. So now all of my units have been figured out. And again, the reason I emphasize don't do multiplication along the process is this first line of work is designed specifically to get all of the units canceled and written in the proper order that we need them to be, which I think in and of itself is a tricky enough part to solve these things. Don't try and do unit conversion and actually find the numbers and all that at the exact same time. I find very often that people will do that and they get lost in their own work and they don't know what they're doing next. So our first step, we just wrote everything out and canceled units. Now we're going to let the calculator do all of this number crunching for us. So I have 4 fractions multiplying together. We multiply fractions straight across. So if I multiply the numerators together, I'm going to have 1 times 24 times 60 times 60. And you can plug all of that into your calculator and it can do that number crunching for you. So I'm doing off screen 1 times 24 times 60 times 60 in my calculator. I'm getting 86,400. Then for the denominator spot, 1 times 1 times 1 times 1, well, that's just going to be 1. So anything divided by 1 is just going to be what we started with, the thing on top. So how many seconds are in a day? 86,400. And we have our final answer there. So we'll move this over here. We'll go on to our second example that we have. So our first example used fractions to go through and solve this thing. Now I'm going to show you guys, I've heard it referred to as, again, the railroad method. I think it's just because of the organizational pattern. But you are more than welcome to use either the fractions or this other one that we're going to go through as we're solving these things. But our second problem is asking us, how tall in feet is the tallest man on record, Robert Wadlow, at 272 centimeters? Here's our problem. We'll go back over to our Blackboard and we'll start working on this thing. So again, first and foremost, before we start writing anything out, we want to identify what units are we starting in, what units are we ending in. We are asked again, how tall in feet is the tallest man on record, Robert Wadlow, at 272 centimeters. So we are starting in centimeters. I don't know why it's doing that. There we go. Starting in centimeters, and we are going to be ending in feet. So again, we want to set that framework for ourselves of what we're starting with and what we should be ending with. So again, I'm going to go through organizing this differently than our first problem, but I'm hoping it's going to become apparent as we go through this. The process is extraordinarily similar. So the railroad method, the railroad way of organizing it, we're just going to make one giant fraction bar here. And similarly to our original problem that we did with number 1, we are starting with our original units and the original number over 1. And then, bam, divide that there. So again, I need to convert from centimeters into feet. I'm looking at the other sheet on our geometry and properties one and the measurements. I'm seeing, is there a direct centimeters to feet conversion that is written in on there? And as I'm looking through that, I am not seeing one. So I need to find something or some steps to go from centimeters to something else and maybe something else and then to feet, which there's nothing wrong with that. So I am seeing that I could convert centimeters into inches. And then somewhere else on the page, I find that there is a conversion between inches and feet. So I can go from centimeters to inches, and then inches to feet, and then I can calculate my answer. So that's the general game plan that we're going to go with for this one. So again, I have centimeters I'm starting with. If I want to cancel that unit, which is currently in the numerator spot, as we have it written right here, if I want to cancel that unit, it needs to go in the denominator spot of our next thing that we're working with. So I'm going to go from centimeters into inches. And then looking at that page again, it tells me that 1 inch is approximately 2.54 centimeters. So now my centimeters are canceled out, and now I am in inches. And I know I have a conversion from inches to feet. That's also been given on that sheet. Inches is in the numerator spot. So if I want to cancel it, inches needs to go in the denominator spot, the next thing that I have. And then feet is going to go in the numerator spot there. And now I fill in the numbers. I've been told that 1 foot is 12 inches. Inches cancel. I'm now in feet, which is the exact same number that I wanted to end with. So fantastic. And now I'm done with this part of the problem. Now I can actually go through and do some multiplication. And very similar to the fraction version of this thing that we just went through, I would recommend working this out as a fraction. And what I mean by that is you're going to let your calculator do this work for you. But multiply everything in the top part together and write it in the numerator of a fraction. Then multiply everything in the bottom part together and put it in the denominator of a fraction. So if we do that, and I'm doing this off screen here, so the numerator, 272 times 1 times 1, which is going to give me 272. In the denominator, I have 1 times 2.54 times 12. And again, use your calculator for that. It's going to be decimals. It's going to be gross. Nothing wrong with that. And I'm getting 30.48. We are working in feet. Let's keep those units in there. And now last but not least, 272 divided by 30.48. I'm getting 8.923, oops, 88, and a bunch of other stuff, feet. Now we were told in the problem to round to the nearest thousandth, which means I'm rounding to there. I look to the number just to the right of it. It is 5 or greater. So that means I am going to round up. So our final answer is going to be 8.924 feet. Okay. So again, just wanted to illustrate for you guys, there are two ways that you can go through and organize all of these problems. I do not care which one you would like to use on the homework. I do not care which one you guys would like to use on the test. If you prefer using the fractions in that regard and separating it out with the parentheses, go for it. If you like the idea of kind of using this, again, the railroad method, as I was originally told was called, you're welcome to do that as well. There's a lot of similarities with what we're doing with these. It's just a different way of organizing for yourself. So on the homework, on the test, figure out which one you're more comfortable with and go ahead and use that as you're going through the process. Nothing wrong with either of these. And if you are working on these on the homework or on the test, I'm not going to grade you as right or wrong with using this method over the other one, because they both get you the exact same answer. So all you guys need to do, pick one of those methods and stick with it throughout the rest of that problem. Okay. So looking at our third example, we'll jump back over there. We're being asked, how many yards is 1,300 centimeters? Let's look at example 3 here. So converting for that one. I'm going to jump us back over to our Blackboard, but work with problem 3 here. So again, we're being asked, how many yards is 1,300 centimeters? And again, before you do anything else, what unit are we starting with? What unit should we be ending with? Starting with centimeters, should be ending in yards. Better S. There we go. Now again, it's your call on how you want to organize this moving forward. I'm going to use the railroad one. I think it's a bit easier to use on this program. I'm just using all of the fractions and everything showing up in there. But again, you're welcome to use fractions with this. You're welcome to use the railroad method, either one. So again, what are we starting with? We're starting with 1,300 centimeters. Always have those units written in for yourself. A lot of people do not do that, or they forget to do that partway through these problems, and a lot of errors show up because of that. So I'm looking at my other sheet and I'm seeing, okay, do I have a centimeters to yards conversion showing up in there? And as I'm looking through it, I'm not seeing one. That's fine. Do I have another thing I could use? Well, as I'm looking through this, I could convert centimeters into inches, and then I could convert inches into feet, and then I could convert feet into yards. So with more steps, but again, we're just going from one unit to the next, one unit to the next, one to the next, until we get to our end result of yards. And there's nothing wrong if it takes you 2, 3, or 4, or 5 times you need to do that. We're going to find some other problems that we're going to get through. I think it's example 4. We're going to have 3, 4, or 5 things listed for ourselves. There's nothing wrong with that. We just need to make sure we're listing everything and having units cancel out correctly. So again, our process for this, we're going to go from centimeters into inches. So starting with what we have right now, centimeters is in the numerator spot. I want to cancel that, which means the unit for centimeters needs to go down below. The new one is going up top. So I'm given that 1 inch is 2.54 centimeters. Centimeters cancel. I'm now in inches. I'm saying, okay, I also have a conversion now from inches into feet. So again, inches up top. If I want to cancel that unit, inches has to go down below in my next one. Inches into feet. Inches cancel. I'm now in feet. Now fill in the numbers. 1 foot is 12 inches. And I'm looking again to see, okay, I need to end up in yards. Is there a feet to yards conversion? Yes, there is. So if I want to cancel out feet in the numerator spot, feet needs to go in the denominator spot in my next thing that I'm working with. And the numbers, 1 yard is equal to 3 feet. So feet cancel. I'm in yards. That's what I wanted to end up with. Great. Now I have everything written out for myself. I have all the units figured out. And now I can just let the calculator do a bunch of the number crunching for me. So in the numerator, I have 1,300 times 1 times 1 times 1. Well, that's just going to be 1,300. It's just that times 1. In the denominator spot, I have 1 times 2.54 times 12 times 3. So multiply everything in the denominator together. You can list all of that at once in your calculator, and it can do that. When I do that, I am getting 91.44. And now we do the calculation, we use the calculator to do that one more time. So do 1,300 divided by 91.44. And again, I'm just using the calculator off screen to do that. You can use yours as well. And I'm getting 14.216972, bunch of extra stuff, yards. Again, we're told to round to the nearest thousandth. So I'm looking at the number directly to its right. It is 5 or more. So my final answer is going to be 14.217, or our approximate answer, I should say, because we're rounding. There we have our answer. Okay. So we're going to go on to two a bit more advanced ones in terms of we're going to have a lot more that's going on with these. We don't know about a lot, but we're going to have more steps involved with this. But I think they're worth seeing because, oops, these types of problems do show up, and it's worth knowing how we go through them. So our next one that we have, I'll jump us over and take a look at that one. So example 4. Convert 75 miles per hour into feet per second. So this is an instance where we're going to have two conversions that we need to do in this problem. We have miles per hour into feet per second. And thankfully it's been told to us pretty well, or pretty obviously, which units are what we're converting to, which is nice. So jumping back over to our Blackboard. Again, still write it out for yourself. And I'd recommend doing it a little bit differently this time. Miles per hour. I'd write that in as miles per hour converted into feet per second. And we should be noticing at this point in time, I have a conversion that I need to do from miles to feet, and then hours into seconds. So we're going to have two different things that we need to convert between in this problem versus our previous ones where we just needed to go from one unit to the next. Our other problem, we have to go one unit to the next one. So here we essentially have two conversions that we need to do, one in the numerator spot, one in the denominator spot. And while these are going to be different spots in our fraction or our railroad, whichever one you are choosing to use for yourself, we're going to go through it using a very, very similar process, but we just, again, need to take this slow and step by step as we're going through and solving this thing. So again, we are starting with 75 miles per hour. So I'm doing 75 miles per 1 hour. Now, when you're doing this, determine, okay, I need to go miles to feet, hours to seconds. Just choose one of those units and just work that one out for now. So I'm going to convert from miles to feet before I do the hours to seconds. Again, take these things in parts. If you try and do all of it at once, 9 times out of 10, this is where I see people make a lot of mistakes. So do it in parts, be very methodical about it. So I'm looking at the chart that I have, that other piece of paper, and I'm looking for, is there a direct miles to feet conversion? And there actually is in there. We know, based on what's been telling us, 1 mile is 5,280 feet. So miles is in the numerator spot of our railroad spot. So if I want to cancel it, miles needs to go in the opposite spot to make it cancel out. So miles to feet. And 1 mile, 5,280 feet. So the miles cancel. I'm in feet in the numerator spot, which is exactly what I wanted to be in the overall problem up here. So excellent. I have the numerator of this thing completely done. I don't need to worry about that anymore. Now I need to worry about and figure out how am I going to cancel hours and get that into being seconds. So we're actually going to follow pretty much the exact same process as we did with our previous ones, except now we just need to put the things that we're canceling in different spots in our fraction. So it's going to look like I don't have a direct hours to seconds conversion on my piece of paper. And I personally don't know of an hours to seconds conversion off the top of my head, which is fine. But I do know that I can go from hours to minutes and then into seconds. So that's the step-by-step path that I'm going to take with that. So starting with hours, if I want to cancel hours, hours is currently in the denominator spot. If I want to cancel that, I need to put hours in the numerator spot of my fraction. And I know that 1 hour is equivalent to 60 minutes. All of this stuff that's right in between that, we are just going to ignore that for now. It's working with different units, it's working with different things there. We can think of that as if it just is non-existent right now. We're now only focusing on hours and converting that. That's all we're doing here. So we're leaving everything else, we're just focusing on time at this point. So here we have the hours canceling out, and I'm now in minutes. And I know that there is a minutes to seconds conversion. I know that I have, for every 1 minute, 60 seconds. And again, minutes is in the denominator spot right here. So to cancel it, I need to put minutes in the numerator spot right here. Okay. Minutes cancel. I'm now in seconds. That's what I wanted to end up with, my final answer. So now I can look at this and say, I have feet in my numerator spot, which is what I wanted. I have seconds in the denominator spot, which is what I wanted. I am done with writing out and setting up everything for myself. I don't need to worry about putting some different units in. I can now just focus in on number crunching. Primarily, the calculator can focus in on number crunching because it's going to do all the heavy lifting for us. But this part of the process, getting all of this written out for ourselves, making sure the units are written out correctly, making sure the numbers are corresponding with it correctly, this is critical to unit conversions. A lot of people do not do these steps, or they kind of just write things down and then write some other things down. They don't really keep it organized for themselves, and these problems become monumentally more difficult without doing something like this to organize your work. Okay, so from this point in time, now I multiply everything in the numerator spot together. So I'm going to do 75 times 5,280 times 1 times 1. When I do that, again, use your calculator. I'm getting 396,000, numerator spot. In the denominator, I have 1 times 1 times 60 times 60. And again, getting a fraction showing up, it's kind of gross. But again, we're going to let the calculator take care of this for us. So maybe 3,960, or 396,000 divided by 3,600. And I'm getting 110. And we have our answer there. So this is the part where, again, the setup using the fractions or using the railroad method, whichever one you want to use, it will look intimidating at first. And I promise you, you're going to have the inclination of, oh, I've got some things written in here. I should multiply things together as I'm going through this. I would highly advise against that, because then you're trying to convert and crunch numbers and keep track of where you are and figure out where to go next all at the exact same time. And that's not easy to do. So just work with setting up the table, work with and focus in on getting the units converted, and then you can do all the number crunching at the very end. And again, let the calculator do all of that for you. At least that'd be my recommendation. Made my life a heck of a lot easier when I started going through these things and doing this, or one of these two methods. I think I originally did the fraction method when I was learning this, and then found out about the railroad one. And I do like both of them. It's dealer's choice in whichever one you would like to use. So our last one, we have some setup that we have to go along with this, but this is another one of our tricky ones. We don't really see these too often showing up, but they are a thing that shows up from time to time. So how many square yards of carpet will it take to cover a rectangular room whose dimensions are 10 feet by 13 feet? So again, how many square yards of carpet will it take to cover a rectangular room whose dimensions are 10 feet by 13 feet? So we have a little bit of setup that we need to do, because we kind of know what we're going to end up with. How many square yards? So you need to figure out what units we're starting in. And square yards generally denotes we're working with an area, some way, shape, or form. We're working with a rectangular room, so the area of a rectangle is going to be base times height, or length times width. We know the dimensions, the length and the width, so we need to figure out what is the area of this room, and then we're going to convert that accordingly. So jumping us over, we know the dimensions to be 10 feet by 13 feet. So the area, again, length times width, so it's going to be 10 times 13, which is going to give us 130 square feet. And it's important that we have that square feet in there because that's working with a two-dimensional object. Excuse me. We're working with a two-dimensional object or two-dimensional shape that we're working with, so we're going to have square feet in there versus just feet. So again, now we're trying to figure out, okay, so we've got that square feet. What unit are we starting with? What unit are we ending with? So we're starting in square feet. We are ending in square yards. So this is an instance where I think the fraction version of this thing is a little bit easier to work with, at least in my opinion. But again, it's your choice on which one you would like to use. So I'm going to work with the fraction version. So I'm starting with 130 square feet. And it's important that we include that squared in there. It's very important in that regard. So I want to know, okay, is there a square feet to square yards conversion? And there kind of is. We know that we can go from feet into yards. That conversion has been given to us. That's on the separate page here. But the issue that we have right now is we are working with square yards and square feet. So we're going to do a slight alteration to what we did previously and how we're going to go through this process. I still want to cancel square feet in the numerator part of our fraction. So I need to put feet in the denominator part of my new fraction. You could call it a conversion fraction or something like that. And I have a feet to yards conversion here. 1 yard is equal to 3 feet. Now again, the issue that's showing up is I have square feet, and over here I just have regular feet. So you have two options in how you can deal with this problem. You can either take this parenthesis that we have and square it. So we put a little squared up here. Or alternatively, you can say, okay, well, square feet is the same as saying feet times feet. So you could also alternatively write out the exact same fraction one more time. This fraction thing is gonna, there we go. So up top we have square feet, which is the same as saying the units feet times the unit feet. And down below we have the units feet times the unit feet, and they will cancel out. So either method you would like to use is perfectly acceptable. I like using the squared, the exponent written in, because I think that's a bit more, it saves us on some additional writing that we might have to do with it. But again, either option you would like to use is perfectly acceptable. So I'm going to put directly down below this, that alternative method, just so you guys have a reference of that readily available for you to take a look at. And again, on the test or on the homework, I am indifferent as to which one of these you would like to use. So here, 1 yard, 3 feet squared. Okay. And we'll find square feet cancel, and we are left then with square yards. So when we are then going through and multiplying this thing out, how do we, oops, let's go to regular white here. Go. So the question is, and this is a very understandable one, well, okay, so if I want to do the number crunching with this, how do I work with setting this thing up and multiplying everything out if I have a parentheses and a squared out front here? It's a really understandable question. So these ones, because they require a little bit more that we're doing, we may need to take an extra step or two to write this out for ourselves. Our units, once again, are all taken care of. So we don't need to worry about the units anymore. We just need to worry about the numbers now. Which again, separate out the units versus the numbers. That makes it a bit easier to keep track of what we're doing. So writing this out just numerically, it's the same as saying 130 times 1 over 3 to the second power, and then you can just write the units off to the side, square yards. So now, multiplying this thing out, we use PEMDAS, our order of operations. Exponents first. So 1/3 to the second power is 1/9. And then you can apply your calculator. We're going to get 130 over 9 square yards. And then 130 divided by 9. Again, just applying the calculator with all of these. And we're getting 14.4444 on forever. We're told to round to the nearest thousandths. That's right here. Look at the number just to the right of it. It's less than 5, so I'm rounding down, which means my final answer is going to be approximately 14.444 4 square yards. And we have our final answer. We'll make that 14 a bit clearer. Should be a 4, not a weird looking potential 9. There we go. So these are the examples we have for going around and working with these this unit analysis and unit conversions. And again, as you are going through these, I'm going to give you guys these optional ways of going through it. So you can write it out for this one. You can write it out this way and solve it. Or you can write it out this way and solve it. Either one works. Just make sure you're reminding those exponents that you're starting with as well. And then in terms of our previous ones, again, I don't mind if you want to use this. It's referred to as the railroad method, as I've been hearing it. To set this thing up and organize it for yourself, go for it. If you really like that one, you can use that. Again, alternatively, if you want to use the parentheses like we did in our first and our last example to set it up for yourself, you're welcome to do that also. I am indifferent as to which method you would like to use to organize instead of your problems. I would just recommend you use at least one of them. And again, the big part that gets a lot of people with these is people try and convert the units and convert the numbers all at the exact same time. And it trips a lot of people up in that process. If you have only like a 1, maybe even a 2-step conversion, I think you can get away with that. I don't think that's completely unreasonable. But I'd be very careful with making sure that you are either multiplying correctly or dividing correctly. Our second example, yeah, it's only a couple things that you would need to do here really quick, but I've seen many a time people will say, oh, it's just centimeters to inches, inches to feet. I'm going to do 272 times 254 and then divide by 12. And our units don't actually work that way to get to the final answer correctly. So make sure you are keeping track of, am I multiplying things? Am I dividing things? What numbers am I multiplying by? What numbers am I dividing by? Things like that. And again, I find either of these two methods to be very, very helpful to take that guessing game out of the question for yourselves. You don't need to worry about that then. It automatically takes care of that and tells you what you're supposed to do. So no guesswork involved, which again gets a lot of people with these problems. And then make sure if you have these multi-step, multi-conversion problems showing up in there, just choose one of them and work with them one at a time. We just chose miles and converted that to feet first. It might take you 2 or 3 steps potentially to get through that, which is fine. But if that does end up happening, and say, okay, I've got my steps here for converting the miles. Fantastic. Once you're done with that, then look at converting hours into seconds or hours to minutes or whatever it may be. Leave everything else in there and just start adding on to the very end of that, the stuff that you're going to cancel out and work with accordingly. So organization, I think, makes and breaks this entire section. I think organization can make it significantly easier, and a lack of it can make this significantly harder. At least that's what I have seen in previous teachings of this class. So this is everything for the 1.10 material. I'll end the recording here and take any questions and we'll move on from there.